So there's one more type of ionic compound that we need to talk about in terms of nomenclature, in terms of naming, and that is ionic compounds that contain a polyatomic ion as the nonmetal. So in these examples that I have here, these are all ionic compounds because they have a metal and a nonmetal, and the nonmetal is the polyatomic ion. So if you remember polyatomic ions, there's a list earlier in the chapter. Those are species that act as a unit, act as a groupie, and they have a charge associated with them. We name ionic compounds with polyatomics in the same way as we do other ionic compounds, except when naming that part of the molecule, the part that has the polyatomic, you don't need to muck around with the ending. You don't need to drop the ending and add "ide" like you would if it was a monoatomic ion. You just name the polyatomic ion. So KNO3 is not potassium nitride, it's just potassium nitrate. And it's nitrate because NO3 is the polyatomic ion nitrate. Read that. MgClO3 is magnesium chlorate. Chlorate is ClO3, -2. Okay. So in actuality, naming an ionic compound that has a polyatomic ion is a little bit easier because you don't have to worry about changing the ending. You name the polyatomic ion as it is, as part of the name for the compound. So I've got some examples here of formulas and given the names. You should be able to go the opposite direction though. If I was to give you the name aluminum hydroxide, you should be able to give me the balanced chemical formula for that. So reading this, the thought process would be, oh, aluminum. Oh, okay, that is a metal. Aluminum likes to be +3, according to the chart previous in this unit, and I believe it was also listed in the ions for chapter 4. Hydroxide, oh, that's a polyatomic. That was on my polyatomic list that I gave you. That is OH, and that polyatomic has a -1 charge. So to write the balanced chemical formula for a species that has aluminum and hydroxide, again, you're going to do the crisscross again. So the charge on one becomes the subscript on the other. We have to remember as well that since I'm going to be having 3 OHs, that I have to use parentheses. Anytime you have more than one polyatomic, you need to use parentheses. So the answer to this would be AlOH3. One more point to make about naming ionic compounds that have polyatomic ions. You may come across the instance where you have a ionic compound that has a polyatomic ion and also contains a metal that can form more than one charge. That's okay. We can still name the compound using the combination of the rules from this slide as well as the rules for naming ions or naming metals that can form more than one charge. So I didn't specify here if I wanted you to name this in the classical or the stock method. If I want you to name a species according to a particular naming system, I will tell you if it involves a metal that can form more than one charge. But when reading this molecule, the thought process should be up chromium, that's a metal. It's on my metal list that can form more than one charge. OH, oh, that's hydroxide, it's a polyatomic. I know that polyatomic is a -1, and there's 3 of them. So the charge associated with that part of the molecule is a 1 times 3 or a -3. So my Cr, my chromium in this case, must be a +3 because I want the charge of the overall molecule to equal 0. So my chromium is a +3 charge, and so my name is going to be chromium 3 hydroxide, or if we were to do the classical naming method system, it would be chromic hydroxide. So that is the last portion of being able to name compounds if they are ionic. In the next video, we will talk about how to name molecular compounds.